All right, this is the lecture for Wednesday, September 8th for physical science. Last class we had talked about calculating density. We talked about some of the basic history of our atom models. What we're going to be looking at from here on out is some information you should have already been taught in your last science class, which was either 8th grade science. Some of y'all have brought it to my attention that your 8th grade year was whenever COVID started. So some of this information may be new, some of it may be not. So let's go ahead and get started. Last class, we introduced the concept of matter. Matter is anything that takes up space, that has a volume, or it has a mass. And normally, whenever we think of matter, we think of elements or compounds. Elements are going to be the simplest form of which matter can take. That's why we have a periodic table of elements. Those are the simplest forms. Compounds, on the other hand, are going to be set ratios of 1 to sometimes 3 different elements. But these compounds are fixed. So if you look at water, there's always 2 hydrogens to 1 oxygen. If you look at glucose, what we were looking at with photosynthesis and cellular respiration, you had 6 carbon and 6 oxygen to 12 hydrogens. So that was a fixed ratio for glucose. So here we have a couple examples. Iron is a specific element off the periodic table. So iron is an element, the same as copper and hydrogen. Now, hydrogen is a tricky one. Hydrogen occurs in twos, but hydrogen is an element off the periodic table. Water and sugar, those are going to be compounds. Oxygen and calcium are elements, while salt here is a compound. So let's look at our different type of mixtures. We have homogeneous and heterogeneous. Homogeneous mixtures are going to be uniform. Generally, you cannot see all the parts. Sometimes you'll see a little AQ next to it that'll stand for aqueous, which generally means it's been dissolved in water. Heterogeneous means it is not uniform, and you can generally see the parts of it. So if you have orange juice and it still has the pulp in it, you'll be able to see the pulp that's mixed in. If you have a homogeneous mixture, this generally means that it is see-through to a certain point. So you have Gatorade or you have apple juice and there's nothing you can see through it. That would be an example of a homogeneous mixture. Milk, on the other hand, you can not see through it. You know that there's little different parts to it. Milk would be an example of a heterogeneous mixture. So let's look. Element, compound, or mixture. Here's an example, chlorine. You can look at the periodic table and it's right there. You have methane down here. That's a compound. That's actually a set mixture or set ratio of 1 carbon to 4 hydrogens. You have air. Air would be an example of a mixture. So I'm going to go ahead. I'm going to give you a couple minutes. I want you to pause here and I want you to look at the list. What do you think iced tea would be? What about chlorine or steel? So pause here, kind of look at the list, and then I'm going to ask some questions. Is it an element? Is it a compound? Or is it a mixture? So looking at what we have here, I can tell you that iced tea is a mixture. Steel is a mixture. That's a mixture between two different metals. Chlorine is an element. Blood, surprisingly, is going to be a mixture. It's a mixture between plasma and your blood cells. Soap is a mixture, as well as brass. Brass is a mixture between zinc and copper. Sodium is an element, and calcium carbonate is a compound. So mixtures are going to have two different parts. Mixtures will generally have a solute and a solvent. Solute is going to be the substance that is dissolving. The solvent is what performs the dissolving. So if I have a glass of sugar water, sugar would be my solute and water would be my solvent. If I had Kool-Aid, my powder would be my solute because it will be dissolved. And again, the water would be the solvent because that will dissolve the powder. So my universal solvent that I will have on this planet is going to be water. Water is our universal solvent for this planet. All right, so getting into our two different types of properties. We have chemical properties and physical properties. Chemical properties will cover aspects such as the toxicity level, the flammability, heat of combustion, heat of formation, is it radioactive? Physical properties are going to be your appearance, texture, color. Does it smell? What are the melting or boiling points? What's the density? Can it dissolve? Or is it going to be considered polar? So make sure you have a good list of what's considered a chemical property and what's considered a physical property. Those two aspects will kind of run hand in hand with our chemical and physical changes, which is our main point for today. So separating mixtures. This is really good for our lab techniques. In lab, when you're going to be asked to decant something, this is going to be a very inaccurate way to separate mixtures. But what you'll be asked to do is to separate layers by simply pouring out the top layer each time. Filtering is kind of like whenever you're making coffee. A filter will catch a solid and separate it from your liquid mixture. Distillation is a little bit more unique. They actually use this whenever you're making alcohols or refining oils. Distillation uses the specific boiling point within two liquid mixtures. And generally, with liquid mixtures, they dissolve or they mix well. So, if you had alcohol and water, you would be able to separate these two compounds by using the different boiling points. So, I could boil off water and retain alcohol in my flask, and water would be condensed down into my test tube. I also have chromatography. This is how we separate our different colors. You have several different types of chromatography styles. Our most common is by taking filter paper and by allowing a solvent to run through it and to break the colors apart, kind of like this. All right, last class we went over the phases of matter, your solids, liquids, and gases. Solids are going to be compact, tight, close together. Liquids are going to be a little bit more free moving. And gases are going to take up the space of the container in which it is present. So we're not going to review that too much. And endothermic and exothermic, we'll get into that during our second semester. That's nothing that you really have to worry about now. What you are going to need to kind of look at is our kinetic energy and our potential energy. Kinetic energy is the energy of movement, That's going to refer to your temperature. Potential energy is going to refer to your stored energy, something that hasn't occurred yet, but it has the ability to actually perform that amount of energy. So, what we're really looking at today is going to be our physical changes and our chemical changes. Physical changes will require that the chemical not change its overall composition. So a physical change would be if I threw a chair at my window and my window shattered. That would be a physical change because the glass was breaking. Chemical changes will require that the actual chemical substance will change into something new. So if I'm looking at lighting a match, that would be a chemical change because I would be taking that match head and I would be striking it, and that would actually burn the wood. Wood, once it is burned, has lost part of its chemical makeup and has turned into something new. A little shorthand is if something cannot be reversed, it's going to be considered a chemical change. If something can be reversed, it would be a physical change. So if I actually took the time, I could melt together the broken glass and reform my window. Now, it wouldn't be perfect because I'm not a professional, but it is possible. If I was to mix salt and sand together, I would be able to reverse that change. Milk, on the other hand, if I left milk out overnight and it started to curdle, when it looks kind of cheesy and clumpy, that process cannot be redone. So, milk souring would be a chemical change. So, if I had ice melting, that would be physical change because you can reverse that. Iron rusting, that would be a chemical change. You're going to dye your hair. That is also a chemical change. Majority of the time, once you dye your hair, you cannot dye it back. So, I know little personal story was whenever I was in high school, I dyed my hair black and I got tired of my hair kind of being such a dark color. So I thought I was going to try and dye it back to being red. And so that didn't really work out. I wasn't able to dye my hair a lighter color. When you dye your hair, it stays that way until the hair regrows. So dyeing your hair would be a chemical change. If you are cutting up a piece of fruit with a knife, now you may not be able to glue the pieces back together, but you're not changing the overall makeup of it. So even cutting fruit up into pieces, that would be a physical change. So that's really where we're ending with our notes. So let me go ahead and look at what we're doing in our class today. So we're going to have to pull up our classroom. And so we are 5A. Your first assignment today is going to be a worksheet. You're going to have to label each part if it's a physical property or chemical property. Remember, physical properties, observed with the senses. It's determined without destroying matter. Chemical properties are going to indicate how a substance reacts to something. Physical changes are going to look more at the shape and size. Can it be reversed or not? But be very careful and make sure to justify your reasons. So, this is our first worksheet. After our worksheet is complete, we also have a lab. You will simply open this up. You will give your definitions for chemical and physical changes, and then you're going to go to each station. Our first station would be baking soda and vinegar. You will click on the link to watch the video, and you will write down observations. Observations are going to change, and then you will explain if you think that this station represents a physical or chemical change. So you have 2 assignments for today. If you have any questions, please let me know. But other than that, make sure you have a great day.